Hello, Dean Compton, sorry, and anyone else watching. I think in particular you were having some trouble making a Voxel Perlin Noise terrain, and then it wasn't behaving very well, and things weren't lining up as you wanted them. So you might have some Perlin terrain over here, and then some Perlin terrain over here, and the Perlin function wasn't spitting out heights that kind of matched from different tiles. So what I'm going to do is make like a simplified version of my previous Minecraft video where we're using one mesh in a complicated way. We were combining different meshes from different voxels or cubes to make a game that ran a lot faster. So here we're just going to use cubes, and at least that means that we can play with different cube types. So we can have like soil and grass and stone and things like this, and even like spheres and stuff. And at least then we can introduce a lot of variety on our terrain. Well, that's the idea anyway. So let's give it a go. So what I've got here is an empty scene, except for the default camera and directional light. So the first thing we might do is go up to assets. No, not up to assets. Go to 3D object. I might make a ground cube, and this is just going to be temporary. And it's just going to give us somewhere to stand so we can see that things are working. So I'll just make it 100 by 100 on the X and Z. No, that's its position, sorry. Its position. I need its scale to be 100 by 100. There we go. So we've got some ground somewhere. And it'd be nice to make that green or something like this. And this could be a material that we use later on for the grass. Green. There we go. Right, that's green. I should call this material something. Grassy. There we go. And we can apply that material to the ground. Right, so we've got a ground. And it would be nice to then walk around on that. So we need a first-person controller. So if we just go to assets, import characters, Unity will have built something already for us, coded something already for us. It looks like I've already imported these. So if you haven't imported those, import those. And what we're after is either one of these, first-person controller or the rigid body. I think we'll go for this one. It's got footstep noises and things like that. So I'll just cancel this. So find the standard assets folder that you've just imported, then go into characters, then first person controller, prefabs, and we want the first person controller. So I'll just drag that into our scene, and we'll put her at 0, no, let's go 50, 50, 50, 50, and then say 5 meters in the air. And then if we run, we should drop from the air and hopefully land on our ground. Okay, this is this is close. Oh, am I on the ground? Oh, sorry, I thought I was hovering really high there. I'm not. I'm just I'm very short in real life, so I got confused. Right, there we go. So we can walk around. We can walk around. Lovely. And there's the sun. Fantastic. Right. So let's get to our terrain Perlin generation voxel Minecraft / script. So back into our asset folder, simple voxels. Right. Last time we had like a voxel farm, and it instantiated, I think it was cube primitives, I can't remember now. But what we're going to do, we're going to make ourselves some prefabs, like different types of blocks, and then attach those to a public game object in the script. So first we'll just make a couple of blocks, and then we'll get scripting. So we'll make a cube, so it's 1 by 1 by 1, and we can make this one a grassy one. There we go. So if we can look at our cube, there we are. So that's what a grass cube will look like. And excuse me, what were we doing? I've forgotten everything. Oh, I want to make him into a prefab, so we should give him a name. This will be grass block. So drag that into your folder, and that will become a prefab. There we are, grass block dot prefab at the bottom there. Okay, so this grass block that is in the scene isn't the actual prefab. We just made the prefab from him, so we could just use this to make a sand or a soil or something. So new material, and we'll call this soily. So I've got to make this some kind of soil colour. Where is brown? It's in orange somewhere. Oh, that was pretty fast. Okay, that's brown. Now I'm going to apply that to the block in the scene. Now remember, this is just an instance of this grass block prefab. So I'm going to rename this soil block. That won't affect the prefab itself. It's just affecting this instance of it in the current scene. It's a soil block. And if I drag this now with its new name into here, it should say soil block prefab. Lovely. So these two are distinct. We've got two kinds of blocks to play with. So we'll play with those when the time comes. We can delete the instance from our hierarchy. Okay, so we've just got a temporary ground, directional light. I need to rename him. I hate calling him directional light. He's the sun. I'll call him Hamlet. There he is. Hamlet, to make him a bit yellower. There we are. Or more yellow. There we go. Right. First person computer. First person computer. We'll call me. And the main camera. We don't need the main camera in there. Delete, because our first person controller has got a camera attached to it. Okay, so we just got these three things in there. So we're going to create a script. So we'll do this in C#, and that will be the simple voxel farm. Okay. Excuse me again. Simple voxel farm. Let's open up this script. There we go. I think the font's large enough for you to see. Make it slightly bigger. There we go. So firstly, we want to create a place where we can put these prefabs that we've made. So we'll just start with a grass block. So we want a public game object, and we'll call it current block type. Okay. So now, if we save this script, you need to save your script before it will kind of communicate with the main Unity environment. If we now attach this script to something so we can see it, so I'm going to make an empty. So, sorry, I've cut this off my recording. If you go up to Game Object menu and go down to Create Empty, you'll have an empty game object in your scene. That's just an object that only has a transform component attached to it. So I'm going to call him our voxel farm. There we go. So now I can add to this invisible object that's doing nothing but being there. I am going to attach the script that we've made to it. There we go. So brilliant. That variable we made, which stores or holds a game object, we can now drag any prefab we like in there as long as it's a game object. So we'll put the grass block in there. So now we've got a grass block kind of ready. We can communicate with it in the code. So what we're going to basically do is when the program starts, I don't think we'll need update, so we can delete him. Right, when it starts, we'll go to generate terrain. There we go. So we need a new function that corresponds to that. Generate what happened there? Generate terrain. There we go. Excuse me. So, what this is basically going to do, I think, is we're going to have a grid, essentially, of, we'll call them columns and rows, which correspond to X positions and Z positions, or rather X positions and Z positions. And then depending on that position, we're then going to calculate a height, so the Y of each individual block that will instantiate according to Perlin noise. So we're going to make a grid of these blocks on the floor. So let's at least try to do that. So in generate terrain, we're going to need a number of X and Z columns and rows. So they're going to be integers. So int cols equals, let's start with 100. In our proper voxel farm, we started with like 50 tiles, as it were. But we can go a bit higher than that. Rows equals 100 as well. And then we're just going to have a nested for loop so that we can iterate through methodically every kind of like slot in that grid. So, or position in that grid would be a better way to say it. So for int x, we'll call these x and z so we can we know what's kind of going on. X and z will correspond to the x and z position in our scene. So start at 0 while x is less than the number of columns that we want, and then x plus plus bracket bracket. Right. So that's our outer loop. That's going to iterate over all the columns, and then we want something very similar for the rows. Z equals 0. Z is less than the rows. Z plus plus. Right, so in the middle here is where we need to create our blocks. So to create a block, we're going to use the game object root with instantiate, and then current block type. That was our variable that we made. So at the moment it is holding a grass block. So in fact, this should already work, but it's just going to create or instantiate one of those grassy blocks, I think at 0, 0, 0, and the rotation is going to be identity, and then the scale is going to be 1 by 1 by 1. So after we've created it, we need to reposition it, or give it the position that corresponds to which slot we're kind of iterating over, so, or position we're iterating over. So all we have to do is say, actually we need to grab hold of this new block that we've made. So we could just say, I would like a game object, and I'll call it new block equals that. Okay, so our new block equals that, and then we can get hold of that new block, like a temporary variable or something. New block transform position equals, let's go into a new line just in case it goes over. We want to create a position. So a position is a vector 3 object, or variable type if you like. So we can do that here by just saying new vector 3, and then just refer to our variables here, x and z. Y we haven't made yet, and z. So it's going to have a problem with y, so we could just say, for now, float y equals 0. Right, save our script, and go back to the unit environment. And we should be able to run it now. I'm just going to take away our temporary ground. We should be able to stand on the new ground. Oh yes, that was very satisfying clunk. Right, so this looks identical actually, because we use the same material. Let's just check that it's working. So I've just paused it. And so if we zoom out, look down, there we go. So we've got a big area that looks like a single cube, but if we click on each individual clone, we can see down here we're looking at individual blocks that are making this up. So there we go. So we have got our voxel farm kind of producing something. So all we essentially have to do now is play with the y component, and then Mr. Compton's issue was, what if we had a few of these voxel farms? Can we align them up and have the Perlin equation be true across the whole field of different voxel farms, as it were? So first, let's get it working for this single voxel farm. So we want to say float y equals something derived from Perlin Noise. So we're going to say math f, is it Perlin Noise? Yeah, Perlin Noise. And so we want to put in 2 coordinates. So it wants to refer to where this block is going to be positioned in the actual scene. So in here, its final kind of position. So that corresponds to x and z. So we could just use x and z. It's going to be the same. We're not moving it in a different place here. So this might make sense in a second if it doesn't at the moment. So we're just going to say x, and that's going to be divided by whatever frequency or gradient we're going to decide in a moment. And then z, not y, z position divided by frequency. And then we're going to scale that up, because Perlin Noise will return a number, I believe, between 0 and 1. So we want to scale it up to the maximum height that you want. So that'll be your amplitude, not avatar mask body. That was an auto correct. Oh no. Let me have what I want. Oh no. Yes, I've got it. Okay, so we need frequency and we need amp. We need to define those. So we could make public variables up here for for those. Sorry. Dear me. Public. What am I doing? Public. Is it a float? Yeah. Public float. Amp for amplitude. Default could be, I don't know, 10 meter high hills, and then public frequency. So this is how spiky you want your terrain, and that should be related to your amplitude, because you know what, I'm not going to explain because I can't get the words out. I know I won't be able to get the words out in a very succinct way, and I know that I've already made videos on Perlin Noise. So if you'd like a bit more explanation here, anybody else watching, then I'll refer you to those. Right, frequency. What am I talking? I'll go 10. We'll fiddle around with this when we get there. So they have an effect in here, our Perlin Noise equation, Perlin Noise calculation. Okay, so I think this should work now already. Is that all we have to do? Let's have a look. Excuse me again. I'll have a drink while this is running. Let's have a look. Wow. It looks like we're on a giant turtle. There we go. Not too laggy at all, actually. So the method we're using, where we're literally just throwing a load of boxes around, isn't going to be very efficient if you're trying to make an infinite world. We could probably do it somehow by manipulating a seed number. You'd have to be kind of clever, by like where the player's looking. You want to put one of these tiles in front of them and remove one from the back, and pre-calculate all the Perlin Noise, and have a pool of these boxes kind of ready. There we go. It's quite fun to jump around here. It looks nice. There's something very satisfying about Perlin Noise rendered into 3D. Okay, so we've done that. So what we need to do is make another of these tiles, which are 100 by 100, and they're attached to this voxel farm object. Remember, it's just an empty, so it doesn't look like anything. And it's literally just using the block type you put in. So if we just drag in a soil block in there, and we can change which is what's nice about public variables is now we can fiddle around with the amplitude and frequency, and we can change how it looks from out here without going back into the code. So if I press play now, it should look brown. There we go. Lovely. Now it's kind of like chocolate, isn't it? That's kind of cool. It's like chocolate world. Right. We need to make another tile. So or another voxel farm. Command or Control D. Voxel farm 2. So at the moment there's just 2 voxel farms in exactly the same position. So we want to do something like, if we've got 100 by 100 tiles as our default, then, and they're 1 by 1 squares that are making up those that tiled grid or voxeled grid, then it's going to be presumably 100 away along either axis, X or Z. Okay, in fact I could make it, let's try 101, just so if it works we could see like a little gap between them, so we can see the difference. Now if I run this now, this happens. Looks exactly the same. If I pause it, I've got just one tile, but very inefficiently kind of rendered over twice. So I was trying to find a way to kind of show that clearly, but take it by my word. Right. In fact, you know what could really show it up is if Voxel 2, if I put Voxel Farm 2, I put grass blocks. What will this do? They're kind of be vying for display. So we can't see any grass blocks anyway. That's because they're slightly underneath these guys. Okay, so what we want to do is relate the X and Z position to where the actual voxel farm itself is positioned. The voxel farm, the original one, that's at 0, 0, 0, 0. And the second voxel farm is at 101 along the x-axis, so it should be shifted 100 along, so we should have those 2 voxel farms. So what we want to do is add like a my position. So and this need only be private, of course, so we can say private vector 3 my position. There we go. And then in generate terrain we'll we will go and grab our position. So we'll say my position, let's have my pos. My position will get in the way when we add it to our equations. So my pos equals now we want to grab this voxel farm object's position. To do that, and the script is attached to that object already, so we can just say this dot transform dot position, and that will grab hold of this empty object's position. Okay, so we've got its position. So this first object's position is 0, 0, 0, and this one is 101. So we've got access to that difference. And now what we can say is place these cubes at my pos plus x and my pos plus z. So the fact that we've shifted along will be relevant to where the block is actually placed. So that should already impact us. Oh, I've got our first bug. I can't see the console readout. Where is that? Vector 3. Oh, of course, we only want to add one component of that vector 3. We want the x component, and for added to the x position, and the z to the z position. There we go. Oh, don't need to save as. Save the script, run again, and we should have now a green and a brown terrain. So we've got our brown terrain. Ah, there's green now. There should be a space between this terrain and that terrain. And we might not line up. So there is a space so that we can see them. I suppose we didn't need the space because they're different colours. But so let's take that out, and we might run across Dean Compton's issue here where we're not lining up our tiles. So I'm really sorry, Dean, if I've forgotten your name. You might be called Dom or David. End of the day for me. I'm very sorry. Mr. Compton, I'll call you. I hope it's Compton. I've really forgotten. It's in my job. I deal with lots of people, and my head is full. Sorry. I've forgotten what I'm doing now. What am I doing? Oh yeah, taking away that gap. Right. So the gap was created by this. Oh, and I've just put in exactly the same number. So we want 100. It's 100 away. Here we go. Okay. We're a bit jumpier than, or have a more powerful leap than in Minecraft. Okay, so the gap has gone away, but now we've reproduced this problem. Look, the Perlin is not lining up. It's not lining up, and that would be a real problem. So to solve that, we've got to make sure that we refer to the actual position that this block is going to be in the world. We've got to take that into account when we're calculating the Perlin noise. So we're not interested in x and z in terms of just the abstract grid. We're interested in exactly where that block is going to be in like the real world, so, or this virtual real world. So if we simply add my pos dot x plus x here, and make sure that that stays together nicely, I'll just bring this onto a new line so we can see what's going on, and we'll do exactly the same over here. My pos dot z plus that. I'll just bracket those off from the frequency divide. There we go. Now, as far as I know, this really should work straight away. So everything should line up. If it doesn't, I have no idea what to do. So here we go. Right. This is quite suspenseful now. Oh, initially it's looking okay. It's looking all right. Yes. There we go. So this is lining up. That is lovely. Okay. So you can then position those all around, and maybe do clever things like removing them and replacing them depending on where the player is looking, and you might have an infinite voxely kind of landscape. Now, to make it look more like Minecraft, I think this looks better than Minecraft because although we have got these gaps going on, look at that. That's amazing. In fact, that might be to do with symmetry. Is that correct? Yeah, I think we've got symmetry. I'm sure. Maybe not. Anyway, let's that's symmetrical. I don't know. Anyway, let's just make it look a bit more like Minecraft in case you were sorry. wondering how to do that. And then I'll bring this video to a stop. And if anyone would like any next steps or further steps from here, let me know in the comments and I'll do that for you. So we're calculating the Y position, the height of each individual block there. So what we could do, we were also going to change the type depending on the height. We should do that as well. So let's say Y equals math. Now we just need to round it to an integer. So instead of being like 1.3 meters from the ground and then the voxel next to it 1.4 meters, we want it to be like 1, 2, 2, 4, something like that. So 3, 4, things like this. So floor might be the best way to go. That just floors it to the integer below or equal to its current floating point number. Floor Y. There we go. Right. So that should work in terms of making it look like Minecraft. As long as the frequency is, like the gradient is low enough, you could still get gaps here. So it looks significantly changed. There we go. But it is actually the same Perlin Noise terrain, but at a lower frequency, if you like. Lower resolution. There we go. And we're stitched together nicely. Okay. It's almost like we've almost made caves accidentally, but it's not really that sophisticated at all. Okay. So, very quickly, we want to, instead of just choosing what block type here, it would be nice to have like a few of them ready stored there, and then our script choose which one to use depending on the height of each block. So first we need to have at least 2 slots. We could do that with an array. So public current block type can now be private, but we do want a public game object array block types. There we go. So we need to go and populate that array, which should change here in a moment. There we go. So block types, we've got 2 to play with. Excuse me. So 0 will be our soil, and then grass block we'll place in there in element 1 or index number 1. Okay, so then after we've calculated our height, we can say if y is greater than, I don't know, our amplitude divided by 2, something like that, then I would like current block type to be equal to block types. Let's put grass on the top. So that was in element 1, I believe. There we go. Else, current block type equals block types 0. Okay. So that should affect both voxel farms simultaneously, of course. They're both using the same script. Okay, so it's all done via that algorithm, if it works. Right, we've fallen off. It looks good as we fall away from it. It looks pretty good though. Why we've fallen down this time, I have no idea. That's genuinely confused me. Why am I not as well in like halfway across? 100, 100. Let's put me 15 high. 100 across. Again, I'm just on the edge. Okay, so this has worked straight away, which I'm pleased about. So I need to stop the video. I don't know how long I've been going. But there you go. Now you can use different block types for different heights and things. What would be cool is to maybe introduce a little bit of a random element to that. So it's only going to be, let's say, grass if it's hit that height and it hits a certain percentage. So you don't get every single one like that. But there you go. I hope anyone who's watched this has been a little bit helpful and will get you going. It is great fun to play around with Perlin Noise. Right. Thank you very much. Goodbye. I can't get out. There we go.